Hello there! I figured it was about time to give you all another update on where the Printalyzer densitometer project is going. By now, I was hoping to have a nice little polished video showcasing the assembly process of the first pre-production prototypes. Unfortunately, I'm not quite there yet. Things have been going well. I have assembled the circuit boards for the first two of these prototypes, a process that is much easier for me to get through if I'm not making a video of it, just because it takes a long time and the camera kind of gets in the way. However, that went well. The big hang-up right now actually is the 3D printed enclosure. So I got the 3D printed enclosure back from the company that's been manufacturing these for me, and I noticed a little whoopsie. There's supposed to be this inner ring here on the bottom piece that separates the outer stage plate from the diffuser for the transmission light, and it's missing. I did some checking and it's my fault, it's a little whoopsie. Whenever you're modifying these things in CAD software, it's so incredibly easy to make some minor mistakes somewhere you don't notice until later. So that's been addressed. In the process of inspecting, I also noticed I needed to tweak a few more dimensions just slightly because the material grows and shrinks as part of the printing process, and you can't really trust on having perfect machine tolerances. So another round of these are on the way. But I was able to kludge things a little bit, 3D printing some replacement components myself, and I've been able to assemble the first unit, which I've been using for software development. And a casual look, it's pretty much going to be indistinguishable, but I really didn't want to make a video until I knew I was doing it right with no fiddling in the process. So this is my first development unit of the final, hopefully final, pre-production hardware. The cover on top is a special one I've been using for development units. It has this hole over here that lets me plug in the programmer debugger. You don't actually need that to update firmware. Just keep in mind for end users, you will be able to update this entirely over USB, so it should be easy. But for development, I do want to plug in the fancy debugger probes. And so I have that on there. I also don't screw the top on just to make it easier. But it will be fully screwed together on the final version. So this is assembled, it's up and running. Hopefully in another week or two, I'll have a little video clip of how this is actually assembled. So the final pre-production hardware, or something close to it, looks very similar to the previous revision. In fact, on the outside, there's very little difference. The most important difference, really, on the outside is the port on the back. So the older prototypes used micro USB, and the new ones use something that's USB-C compatible. The main reason for this is just future-proofing, and I want to be compatible with whatever cables and adapters people have laying around today versus what they might have left over from a few years ago, just to be safe. So that's coming along well. The software has been updated. It is now up and running. Everything's good. In fact, at least externally, the only changes I expect between what you see here and the final version of this is the buttons are going to be a little shorter. I had a special order the shorter buttons, so those aren't here yet. And somewhere in between, I realized I probably want to add another rubber bumper to the bottom, because otherwise, when you're pushing down on it, sometimes you tend to flip it over. So other than that, the final one is going to look pretty much like this. So how's the project proceeding? Well, right now, I'm trying to get these first two pre-production prototypes fully assembled and good to go. And once all the details check out, I'm going to build several more for certification, testing, and evaluation. I'm hoping to be able to send a few beta units out to actually get feedback from real users as soon as I'm ready. I'm not going to do it when I don't have enough to go around, but hopefully I will soon. Another piece of good news is in my last video, I mentioned there was one component that had been backordered out to August. Well, thankfully, that problem's been solved. I found another distributor that got a large quantity of these in stock recently and ordered some, so now the only thing holding me back from going to production is basically me, which is a great place to be. What this means is I should hopefully be able to go to production sooner than August if everything works out well, but there's still a lot of things that I have to do. So that's where the project stands. Next step is to put together the second prototype and then go through a full small run of them. And then it's time for certification and evaluation. One thing many of you might be wondering is why all of the product photos currently available for this device are in blue, but all the prototypes I've been showing off lately are in black. Well, the reason for that is I've been evaluating a couple of different 3D printing technologies for this project, and I've actually changed my mind since taking those photographs. So the two technologies under evaluation have been SLS, which stands for Selective Laser Sintering, and MJF, which stands for Multi-Jet Fusion. Now, SLS has the advantage of coming in many more varieties of color, but the disadvantage of being a somewhat translucent material. So in order for SLS to work, I had to print some of the components in the optical path of the device on a more conventional FDM 3D printer. And then I had to glue those pieces together. With MJF, I could do it all in one go. The problem really came down to manufacturing tolerances. On paper, SLS and MJF are almost identical. They're both very good technologies. However, the user of the machine matters. And if the 3D print is coming from a company who doesn't really care about me as a customer, then SLS beats MJF on tolerances every day of the week. With MJF, the allowable slop that most 3D printing companies could get away with was enough that the parts wouldn't fit together. This was just completely intolerable. The solution was to develop a private relationship with a company that does MJF printing, that knows how to run the machine, and cares about me as a customer. That makes all the difference in the world and gives MJF the tolerances I actually need for this project. So, in any case, there's the latest update, and if you have any comments or questions, please leave them below, and I'll talk to you later. Bye!